All right, so what I'd like you to do is open up to page 8 in your notes packet, and we're going to be looking at number 11. Okay, so now remember when we have a system of equations here, I am going to take that 2x minus y equals 4, and I am going to get y by itself. So I'm going to start by subtracting 4 and subtracting 4, okay, which will get rid of this. And at the same time, well, let me rewrite this. 2x minus 4, and then I have minus y equals 0. And then I'm going to add y and add y. Okay, you should be taking notes in your notes packet. So that's going to give me 2x minus 4 equals y. Now I'm going to take this value right here, and I'm going to plug that right into the second equation where I see the y. Okay, so I'm going to rewrite that as x plus 3, that quantity squared, plus, and now I'm substituting in my value that I just got, which is 2x minus 4, that quantity squared equals 8. Okay, so again, I just took my, oops, hold on a moment there. There we go. I just took my y value and I plugged it right in here, and this is what I got. Okay, so now we're trying to figure out whether we have imaginary, irrational, rational, so on and so forth. So I am kind of thinking I want to go toward the quadratic formula because I see I'll have a better idea of what I'm doing from there, and just hold on if you're not following what I just said. All right, so let's just kind of continue along the whole algebraic path here. So I'm going to double distribute x plus 3 and x plus 3. And then I'm going to double distribute 2x minus 4 and 2x minus 4 and set it equal to 8. All right, so I'm going to get x squared plus 3x plus 3x plus 9. And then on the right, when I double distribute, oops, I'm sorry, that should be a plus sign, shouldn't it? Okay, so let me just kind of reiterate, this plus sign here is that plus sign there. Sorry about that. Then I'm going to get 4x squared minus 8x minus 8x plus 16. And while I'm at it, I'm going to take this 8 right here and I'm going to scoot it over on this side. So I have to subtract that, right? So minus 8, and then we're going to equal 0. Okay. So at this point, what I'm going to do is I'm very carefully going to look for like terms. So I see an x squared and a 4x squared. So that is going to be 5x squared. And then I see a 3x and another 3x, which is 6x. But then I have here minus 16x. So that altogether will give me minus 10x. And then I'm going to look at my constants. I've got a positive 9 and a positive 16, which is positive 25. But then I'm going to subtract 8 from that, which is going to leave me with a positive 17. And we're going to set that equal to 0. And now everything is set up so that I can do the quadratic formula. Okay, so I have my A is 5, my B is negative 10, and my C is 17. Okay, again, please make sure you are taking notes. So I'm going to have x equals negative b, which is going to make that a positive 10, plus or minus the square root of, we've got b squared, so that's going to be negative 10, that quantity squared. Please put that in parentheses when you put that in your calculator. Okay, all right, then we've got minus 4 times 5 times 17. And that whole thing is going to be over 2 times 5. All righty, well, I'm going to go 10 plus or minus, and now all I'm going to do is just, in my calculator, open a set of parentheses, put in negative 10, close it, square it, minus 4 times 5 times 17. Don't put the radical in your calculator, just the numbers underneath. Okay? All right, so take a second and do that. Pause me and get an answer, and then unpause the video. All right, so you should get negative 240, right? And this whole thing's over 10. Well, listen, guys, it's multiple choice. We don't need to go any further because we know that that is a negative number. And we also know that a negative number under the radical is imaginary. Okay, so we can say then that the answer is choice 1. Looking at number 12, it says algebraically determine the roots. So we have to do this obviously without a calculator. Also, it says in simplest a plus bi form. Please remember, when you see simplest a plus bi form, I know I'm doing quadratic formula with that one, no doubt. A plus bi form, always do quadratic formula. Okay? So if you feel confident enough, which you should, I'd like you to pause me, work on this, and then when you're done, unpause the video and check your work. All right, so I'm going to get everything to the left-hand side. And so I'm going to subtract that 4x over, and I'm going to add 10 as well. And I know this is going to look a little gross, sorry. But I'll be doing the same thing on the other side of the equal sign, and those guys will cancel out. All right, so when I do that, I get x squared minus 6x plus 17 equals 0. So my A is 1, B is negative 6, and C is 17. Okay, so let's go along here. So x equals negative b, which will be positive 6. And then we got a square root, and we've got negative 6, that quantity squared. Please put it in parentheses. Minus 4 times 1 times 17. All over 2 times 1. And remember, when you're putting what's underneath the radical in the calculator, don't put the radical in the calculator, just what's underneath. Don't forget your parentheses, though. Okay? All right, so we're going to get x equals 6 plus or minus the square root of negative 32, all over 2. Okay, so I know that I'm going to have an I, right? And so I'm going to put that outside because I have a negative underneath the square root. And I would break this down to 16 and 2. Remember, you can always go into your calculator, go into y equals, and do 32 divided by x. Okay. So if you remember, the square root of 16 is just a regular 4. Please don't put a radical 4. It's a regular 4. So you're going to have x equals 6 plus or minus, and that is going to be 4i radical 2 over 2. Now you always want to simplify your radical first. So some kids are tempted, oh wait, 6 divided by 2 is 3. Don't simplify here. Wait until after your radical is simplified, like right here. And now you can say, oh, I have a common factor of 2. All 3 of these is what you're kind of looking for when you're trying to figure out if there's a GCF. So I see that 2 goes in here 3 times, 2 goes in here once, and 2 goes in there 2 times. Okay. All right, so let me just rewrite this. And I've got x equals 3 plus or minus 2i radical 2. And that would be my answer. All right, so if you look at part B, it says to look at the system of equations, and the graph of this system confirms the solution from part A is imaginary. Explain why. Take a minute, put both of those into your y1 and your y2, and get a graph, okay? And then just draw a little sketch, and then unpause the video. All right, so this is what you should have, and hopefully you're noticing that regardless of how far up to the left this goes and up to the right this goes, as well as this going up to the right and down to the left, these two graphs are never going to meet. Okay, so they have no real solutions then. And if two graphs don't meet and they have no real solutions, then that means it would confirm our part A, which if you go back and you look at your part A answer, we have imaginary solutions. Okay, we had x equals 3 plus or minus 2i radical 2. Those are imaginary solutions, meaning that these graphs will never intersect. And then I would say something to this effect, where the graphs don't intersect, therefore no real solutions. The solutions would be imaginary. All right, so in number 13, and again, please make sure you're taking notes in your notes packet, they gave you the graph of g of x, which we can clearly see is a parabola. And they say, what is the solution to the system of, and it wants both of these. So obviously what we need to do is we need to graph that. So let's take a minute, and why don't you pause the video and graph that. Okay, you're going to have to pardon my horrible graph here. I'm sorry, my stylus is not agreeing with me. So basically, I should be starting down at -2, which is supposed to be down here. I apologize. And then you're going to go up 3 over 1. So there's 1, 1. There's one intersection point. Okay? And then you'd go up 3 more over 1, so on and so on, so on and so on. And then they will meet at 6, 16. Now, it says, if you look at the question, it says, what is the solution below? So again, if you went down 2 and then up 3 over 1, you would see 1, 1 is one of the solutions. And if you go over here, the only one that's got that is choice 4. Okay? Now, I just want to draw your attention to what I drew, or what I wrote down here. So here's y equals 3x minus 2 right here, right? Okay, so I looked at this parabola. Another way to do it is you could say, oh, well, that parabola is y equals x squared, but look, it's shifted to the right 2. So remember, when you shift something to the right, it's going to be in parentheses, but you're going to have the opposite sign. So this is the equation of that parabola. So another way you could have done it was you can put this in your y1, and maybe you want to try this. Put this in your y2, okay? And then you can go to your table of values, right? Hit second graph, and then you can see the intersection points 1, 1 and 6, 16. All right, so I just kind of took a little picture of my calculator so you can see. So here would be the graph if I plugged this in my y1 and this in my y2, or, you know, this can go in your y1 and that can go in your y2. And you can see I can't see that intersection point there. Now, I can change my window, but it's kind of really not necessary because I'm just going to go to my table. And so this is what I'm talking about right here. Look. So this is how I know that I have an intersection point of 1, 1, because at x equals 1, the graph that's in my y1, which for me was my 3x minus 2, and the graph that's in my y2, which is my parabola, both have the same y value, okay? And then if you look down at the bottom here, 6, 16 would be my other intersection point. So that is how I'm getting the answer of choice 4. All right, so number 14 wants you to graph f of x and g of x. So you're going to take a moment, you're going to pause the video, put f of x in your y1, g of x in your y2. Get solid points because it does say graph, it doesn't say sketch. All righty, so here is my pretty pathetic looking graph. But if you follow everything correctly and just plot the points that are in your y1 and your y2, this really should be pretty straightforward. Don't pick any points that have fractional values or anything like that. That's not necessary. And if you read the question, it's just asking you to state the number of solutions, not what they are, but just how many. State the number of solutions. And this just means where they intersect. So I see 1, 2, 3 points of intersection. Okay, so let me circle those for you. There's 1, there's 2, and there's 3. So your answer is 3 solutions. All right, at this point, my honors class, I would like you to also do number 9 and 10 in your notes packet right now. And then when you're done, go on Google Classroom, go to Unit 5, the answer keys, and check your number 9 and 10 with the answer key that's on Google Classroom, okay? And then when you're done with that, along with my regular kids, all you guys listening, I want you to do the Delta Math. It's system of equations, and it's due Sunday night, okay? So with any remaining time, you're working on the Delta Math homework.